Now in part one, I left you with this page because it was just so much. I should have gone one slide further. So on this page, what we did is we solved for m. Let's see, is that 1, 2, 3, 4, 5 different ways. 5 different ways we solved for m. Okay, so, but look at the next page. The whole reason we did all that is because then here we use the literal equation that we just got to be this, and it makes it look like, oh, just use this nice little formula and plug it in. But we know what we did to get there. Okay, so we have to use this to solve. And this is where, if we were using literal equations, they would give us like several different ends. So then we could see what was happening. Okay, it's used a lot in science. But all we have to do is take our equation and plug in 40 for n. So I'm just going to plug in what's n equal to 40. Now you're just going to simplify this expression. So I get m is equal to, cancel, divide by 4, so divide by 4 and I get a 10. So 50 minus 7 is equal to 43. So the reason for literal equations is so that if I'm doing several different experiments and they want to find out, well, what happens when n is 40? What happens when n is 50? What happens if n is 1? Okay, then I can just plug it in all these different times instead of having to solve the equation. Okay, that's the whole reason we do literal equations. Moving on. So these problems are not in your book. These are not in the book. You'll notice the numbering. I left that. The reason for that is because these are the evens in your book and you're going to be doing the odds. So this would probably be a good time to pause your video and get out your spiral notebook where you've been showing your work and put these in as part of your notes, but it gives you some space to work it. Okay, so pause your video, go get that math notebook where you've been doing your homework and indicate up at the top, this is notes for lesson 4. Okay, topic 1, lesson 4. So these are some notes in topic 1. Okay, so here we go. We want to start off by just practicing. We want to get y by itself. Okay, we want to get y by itself. So do that first step, try it on your own. And hopefully what you did is you subtracted a from both sides. So we have k minus a is equal to negative y. Now some of you might have wanted to add because you see subtraction here, but this subtraction, okay, we have to get rid of the a. How does that add to 0? I'm going to have to subtract it. Okay, now the tricky part, remember, is we always want to indicate what variable we're going for. And if I do that, see how obvious it becomes now? What I'm really doing is I have to get rid of that negative. Like, how do I get rid of a negative? Well, remember you can always put that this is a 1. If I have it connected by multiplication, that's a negative 1. So now you have the option here. Am I going to divide the whole thing, or am I just going to do each individual part? So I'm writing it out again on purpose. So first, I'm going to divide every single part by negative 1, by negative 1. And therefore I get negative k plus a is equal to y. Now, the answer in the back of the book, if you had a back of the book, would be a minus k equals y. These are the same answer, okay? Now, the other way I can do it is we can just divide the entire thing by negative 1. And in this situation, it would be kind of ridiculous to do it, but you could. And so then we get k minus a all over negative 1 is equal to y. And then we wouldn't leave it this way. We don't leave a negative in the bottom, so we bring that negative up, and I get negative k plus a is equal to y. Okay, good. Now, on 18, this one's pretty nice. You're solving for n. Okay, I'm going to give you a brain break for a second. Get n by itself. Go. Pause your video and go. So, on this one, you did it one of two ways. You either divided the entire side by n, or you broke it up. Okay? So I'm going to do both ways because I want your brain to see both ways. So I'm indicated that I want this variable, and then on this one I'm going to divide both, just the entire side. So I get n is equal to 4x plus 2v all over n all over 2, and then I can break it into my two fractions of 4x over 2 plus 2v over 2. So my final answer, n is equal to 2x plus v. Okay? The other option is that I can go and do each individual term by 2, and I get n is equal to 2x plus v. I show you both so that your brain can see both. Yes, I get the same answer either way, but you will have multiple choice tests in your life, and I don't know what they're going to give you. So you need to see that these are equivalent. So I want you to know how to break those apart. Okay, looking at number 16, we want to get x by itself. How is x connected to AB? Hopefully you said it's connected by division. And if I have division, what do I do to get them apart? I multiply. So I'm going to multiply both sides by a minus b. Multiply both sides by a minus b. And when I do that, I will get w times a minus b is equal to x. Ah, and I'm done. See how easy that was? Good. Let's practice some more. So these are some more evens out of your book, and you're going to be expected to do the odds. This first one is like, what the heck? So we are solving for m, but here's what's unique about this one. We have an m on both sides. So we're going to have to really work on this one. And we can't really do too much with that 12 and 18. We could, but it's pretty complex. I wouldn't. So let's just distribute here. So we're going to distribute. I'm going to move it over here because I know this is going to take some space. 12m plus 36x is equal to 18x minus, what is 18 times 3? 24m. Okay, now what we're going to do is that we're going to isolate that m. Oh, now the keyboard comes up. Okay, so what we're going to have to do is we're going to have to get the m's on one side, everything else on the other side. Okay, we've done this before many times. So what do we want to move? I'm going to move the 24. So I'm going to move the 24 over by adding 24m to both sides. These are just like terms. So that's going to give me 36m plus 36x is equal to 18x. What are we trying to get by itself? M. So we're going to isolate that m. So now let's move the 36x. So I subtract 36x from both sides. And I get 36m is equal to, what did I just write down there? Man, can't even read my own handwriting. That's a 36. Okay, so I'm going to add 18 and 36, and I come up with a negative 18x. Yes? Hopefully you can read all my handwriting. This is a 36. And I forgot my 36 on this side. So first off, I'm going to subtract 36x. Then I get 36m. Oh, this pen and I are going to have our ways. 36m is equal to negative 18x. Okay, what am I trying to isolate? I'm trying to get that m by itself. How are they connected? Multiplication, so you're going to divide. Wow. Okay, so here we go, 24. We want to get h by itself, so we're going to indicate that. Now we're going to look at what we have. Wow, we have a fraction. We have all kinds of things. So I'm not going to do it 20 million ways. I'm going to tell you what I would start with. You can do it however you want to. And if you want to pause yours, try it on your own. So the first thing I would do is I'd get rid of that fraction. I almost always get rid of fractions first. So I'm going to just kind of draw a little line over here so I have more room to work. I have 3v is equal to pi r squared times h minus 1. I'm going to isolate that h. I'm going to divide through. So now I'm looking, pi r squared is connected by multiplication. I'm going to get rid of those. So I'm going to divide by pi r squared. Now I'm going to have 3v over pi r squared is equal to h minus 1. Get the h by itself. What am I going to do? Add 1. Exactly. So my answer turns out to be 3v over pi r squared plus 1 equals h. Now I put it down here. I'm not going to put it in the denominator. It has to be up all by itself. Okay? Questions? Oh, I wish I could be there with you and answer your questions right now. Pause it, go over it again, rewind, okay? Let's look at number 26. And again, we indicate our variable. We're solving for y. So look at this one. We have this m down here. It's connected by multiple division. So let's get rid of it. Let's clear that fraction. We're going to clear a fraction, and our denominator is an actual variable. So we get mx is equal to 3y times the quantity y minus b. Okay? Now you might be saying to yourself, why did I write m and then x? Because if I have two variables together, I write it in alphabetical order. Okay? It's not wrong if you have xm, it's just that you put it in alphabetical order. I want to solve for y. Okay? Again, I have options. Oh my gosh, sometimes I wish I didn't have so many options. I'm sure you're feeling that way too. So I could start off by distributing right here. I could start off by dividing by 3. I'm going to distribute, and I'm going to move my work over here. Okay, you don't have to do that because you hopefully have plenty of space. So I'm going to rewrite mx is equal to 3 times y minus b. I'm not even going to show you different options, but I could divide by 3 here. And those of you who took advanced 7th grade math, you'd probably see that. Divide by 3. Oh, yes, I am. Okay, I'm going to do it twice. So here we go. I'm going to do it over here. I'm going to divide by 3 over here. And when I do that, okay, you don't have to make such a mess. You have all your work right there. I have mx over 3 is equal to y minus b. Sorry, I'm out of space. I could then add b to both sides. And if I do it this way, my answer would be mx over 3 plus b equals y. That's one way I could do it. The other way is I could distribute it. Okay, and again, what does your brain see? That's what we're going for. What does your brain see? That's the reason I give you so many options, not to blow your brain, okay? So I'm going to distribute first 3y minus 3b. Then I'm going to move things. I'm going to indicate my variables so I don't forget what I'm moving, okay? Now I'm going to move the 3b by adding 3b to both sides. So I get mx plus 3b is equal to 3y. Now I can do that 2 different ways. So I can divide all of it by 3. And you know what? We're just going to do it this time. I'm worn. Oh no. I need more space. So pause for a second. I rewrote the problem up here. So I took all of this and I rewrote it up here. So now I'm going to write it out the 2 different ways. I could have mx plus 3b is equal to 3y. And I'm going to just write that twice. Now I'm going to go through and I am going to divide both sides by 3. Whoops. First I have to indicate the variable. That was a mess anyway. So I'm going to indicate the variable. Now I'm going to divide both sides by 3. I'm just going to do the whole big chunking thing. And I get mx plus 3b over 3 is equal to y. I can then reduce that down to be mx over 3 plus b because I can break it into 2 fractions. 3b over 3 is equal to y. So then I have mx over 3 plus b is equal to y. Or I can go with that. I divide each term by 3 and I get mx over 3 plus, cancel out my 3's, b is equal to y. Wow, okay. So, lots of different things. Let's go to some other problems that we're going to be isolating variables and getting the literal equation. Okay, so this one is in your book. I believe it is on page 14, but you're probably bright enough to figure out what this problem is, probably page 14 or 15. Find that. Okay, and this one says the high temperature on a given winter day is 5 degrees Fahrenheit. What is the temperature in Celsius? So what this is referring to is if we're going to convert from Fahrenheit to Celsius. So the first thing we need to do is we need to get what these formulas are. I don't have these memorized either. I know there's a 9 and a 5 and a 32 and some other numbers and a C and an F, but I don't even have these memorized. So what I did is I went out and I found the formulas. When you go out and find the formulas, and if you have some time, pause yours and go out and do this, because you'll find that when you do it, internet is so awesome that all you have to do is plug in the information and it will convert it for you. So you're going, why do I have to know how to do this information you're teaching me? Because somebody had to write that program, for one. The other is, what if you don't have internet accessible? You're out, you're a surveyor, you're a scientist, you have to be able to convert these. And so this is one of the skills that we need to know how to do. So I'm going to tell you those formulas, and then we're going to go and convert them. So we're going to start with the formula that says Fahrenheit is equal to 9/5 C plus 32. Okay, and this time we're trying to get C by itself. I know a lot of you right now are going, well, just plug it in and solve the equation, which we could, but our whole point of today's lesson is to learn how to write a literal equation. So we're going to get C by itself. Here we go. We're going to subtract 32 from both sides. So we get F minus 32. You have to be able to read what I'm writing. 32 is equal to 9/5 C. Now we could have started by clearing the fractions. Okay, we could have multiplied through and just cleared the fractions. Okay, now on this one, if it were me personally, I would just multiply through by 5 and then divide by 9. And I'll do that, but I'm going to actually do the way that you would see it. If I were looking up these formulas, what they do is, remember who writes these are mathematicians. They're going to get rid of that entire fraction. So what they're going to do, and what it looks like, is that we multiply both sides by 5/9, multiplied by the reciprocal. So I'd have 5/9 F minus some lovely number, 32 times 5 over 9. Of 160 over 9 is equal to C. That is 160, if you're wondering. Okay. And, or, they don't go that far. They just stop right here and say C is equal to 5/9 times F minus 32. And they just stop right there. So they don't distribute it out. They just stop right here. This is the formula for Celsius in terms of Fahrenheit. This is the formula for Fahrenheit in terms of Celsius. Okay, so you can see you're going to have to switch back and forth, and it tends to be a question that's always asked in literal equations, so make sure you're familiar with it. Now, we're going to go find out what the temperature would be in Celsius. So, we have Celsius is equal to 5/9 times F minus 32, and we plug in 5. Okay, now we're going to simplify this, do what's in the parentheses first. So we're going to multiply, we're going to simply take 5 minus 32. We come up with a negative 27. And now we can cancel out our 9s or just use your calculator, but I'm going to show you again. If I divide through by 9, I get a -3, so I get a -15. So the Celsius temperature is -15 degrees. I know you're wondering, why did I do all this over here? Because I want your brain to get used to it. Okay, I think you've had enough of your brain getting used to it. So there are some other ones that I could show you, but we're going to just stop right there and hope we're good. I think we are for homework. Thank you very much for staying with me, and I'm going to stop. If you have questions, you know where to find us. Thank you very much.